All right, welcome back everyone. Today we are moving on to lesson 7.4 and we are starting our division properties with exponents. All right, so to start we are going to do a little bit of a warm-up. So x squared raised to the third. All right, again, I'm just going to expand this one out just to give a nice visual of what's going on. So x squared raised to the third means that x squared gets multiplied by itself 3 times. I could expand it out even further and say it's x times x times x times x times x times x. Right? Each of those x squareds is an x times x. So we have x times x times x times x times x times x. So this is x to the 6th power. X multiplied by itself 6 times. Now if we used our exponent properties, all right, since we have a power raised to another power, this is where we would multiply our exponents. So raised to the 2 times 3 power, which would still get us to x to the 6th. All right, number 2, we have 3 squared times x to the negative 1st. Well, I know that 3 squared is 9. X to the negative 1st is 1 over x. So if we multiply straight across, we end up with 9 over x. All right, I could have written it as 9 over 1. So 9 times 1 on top is 9. 1 times x on bottom is still x. So we get 9 over x. All right, now number 3. We have the same base of 3, an exponent of 8, and an exponent of negative 2. So here, since we have the same base, we can use our product of powers property, which means we add the exponents. So we would have 3 raised to the 8 plus negative 2, which is 3 to the 6th power. And if we grab our calculator and do 3 to the 6th, we get 729. All right, so now let's get into some new stuff. All right, so these first couple tell us to expand and simplify. So 3 to the 5th, when we say expand, that's 3 times 3 times 3 times 3 times 3, 5 of them. Over 3 squared is 3 times 3. Well, the nice thing here is that everything on top is multiplying and everything on the bottom is multiplying. So if that's the case where everything's multiplying, a 3 on top cancels with a 3 on bottom. Another 3 on top cancels with another 3 on bottom. So we're really only left with 3 times 3 times 3, which is really just 3 cubed. So if we do that, we get an answer of 27. Right, you should have gotten the same thing even if you just did 3 to the 5th divided by 3 squared. You still should have gotten 27. All right, number 2, if we expand this one, 5 to the 6th over 5 to the 4th, 5 times 5 times 5 times 5 times 5 times 5, all divided by 5 times 5 times 5 times 5. So 6 of them on top, 4 of them on bottom. And again, everything is multiplying on top and bottom. So because it's only multiplication, a 5 on top cancels with the 5 on bottom. Another one cancels, and another one. All right, so what we are left with is just 5 times 5, which is 5 squared, or 25. All right, so we're just going to do a couple more examples, actually. All right, so now I've jumped down to the bottom of the page. Oops. Okay, so I have x to the 4th divided by x to the 3rd. Now I'm still expanding all of these out. So on top, I would have x times x times x times x. And on bottom, I would have x times x times x. So again, all of our x's on top and bottom are multiplying. So we can look to cancel some things off and make it easier. So an x on top cancels with an x on bottom, and again, and again. And this time we're only left with just a single x. All right, so let's try number 4 then. X to the 7th over x to the 4th. X to the 7th is x times x times x times x times x times x times x over x to the 4th, x times x times x times x. And now still with everything multiplying, we can cancel off 4 of the x's on top with 4 of the x's on bottom, leaving us with just x cubed being left over, or x times x times x. All right, so jumping down to number 5, you might notice something different this time. This time we have a y to the 5th on top, so 5y's over x times x. Now we can only cancel things on top and bottom if they're exactly the same. Since y isn't the same as x, we can't cancel anything off. So we're left with y to the 5th over x squared still. All right, so then on number 6, it gets a little tricky. All right, I could write x to the 4th divided by, now x to the negative 2nd, remember, is 1 over x to the 2nd. So if I don't like dividing by a fraction, remember we can always multiply it by the reciprocal. So what that means is the reciprocal of 1 over x squared, that needs to get flipped to just x squared over 1. So when we multiply, I have x to the 4th times x squared over 1. I could also write this x to the 4th over 1. And so now we can really see we just have x to the 4th times x squared. So what I could do is add these exponents to get me x to the 6th. So our final question before we move on to some practice is, what do we notice? Well, I noticed that if we look at our exponents and where we ended up, the difference in the exponents is what was left over. So on number 1, we had 3 to the 5th over 3 squared. The difference of 5 and 2 is 3. We ended up with 3 to the 3rd. Number 2, 5 to the 6th over 5 to the 4th. The difference of 6 and 4 is 2, and we ended up with 5 squared. X to the 4th over x cubed, number 3. All right, we ended up with just an x, so x to the 1st. And the difference between those exponents, 4 and 3, was 1. Number 4, we started with x to the 7th over x to the 4th. The difference between 7 and 4 is 3, and we ended up with x cubed. Number 5, we couldn't really touch because we had different variables. So if we look at number 6, what's the difference between 4 and negative 2? Well, let's think about it. The difference means subtraction. So if I do 4 minus negative 2, remember that's really 4 plus 2, which gives us 6. And what do you know? That matches our exponent. All right, so what do we notice? Let's say when we divide exponents with the same base, all right, and I'm going to underline same base. All right, just like in number 5, we couldn't do anything because y is a different base than x. So when we divide exponents with the same base, we subtract the exponents. All right, so when we multiplied with the same base, we added the exponents. When we divide with the same base, we subtract the exponents. right, so they kind of go hand in hand. So if I were looking to create some sort of formula to use, or rule, if I had x to the mth power divided by x to the nth, we would have x to the m minus nth power. And that is our rule. All right, so on this next page, maybe you noticed our property is at the top. X to the m over x to the n, and we just subtract our exponents. All right, so the rest of this page is yours for practice. So go ahead and check out the second video that's posted to see how these problems were done.